Hey everyone, and welcome back to the channel. Today we are continuing the Power BI to Microsoft Fabric Transition Guide series with a very important one. Now, one of the biggest mistakes that people can make when they're moving to Microsoft Fabric is to select the wrong data store. So in Fabric, there's three main data stores. We've got the Lakehouse, the Data Warehouse, and the KQL Database. And each of these have slightly different characteristics, use cases, features, and also limitations. And if you don't fully understand these things, then you might not make the right decision for your requirements in your business. So in this video, we're going to be going through each one in detail, understanding what they are, what they should be used for, again, understanding the features and the limitations and comparing them side by side. And then in the second half of the video, we're going to be learning about how you can combine these different data stores into some sample architectures. So we were going through some use cases. Typically, these aren't just used on their own, but in Fabric, you might be using one or two lakehouses plus a data warehouse, maybe a KQL database as well if you're using real-time data. So that's what we've got in store for you today. Enjoy the video. So to start us off today, I'm actually going to start in the OneLake File Explorer. So this is a plugin that you can download and it acts a bit like OneDrive for your local machine. And the reason why I'm going to start here is to understand that under the hood, the Lakehouse, the KQL database, and the data warehouse, they all store their files in the same format. And this is particularly visible when we look in the OneLake File Explorer. So here I've connected it to my Fabric environment and we can see different artifacts, different Fabric items. And when we click on it, it's just folders. So we've got a tables folder, and then these are tables in my Lakehouse. This is a Lakehouse. And if we click into this, you can just see the parquet files and the delta log. So these will be JSON files that just show the delta log for that particular table in the Lakehouse. And if we go to another one, so this is my workspace. If we go to, for example, this data warehouse, you'll see that it's exactly the same structure. Tables, we do have a schema in the data warehouse. But if we click through, then we can see that, again, we've just got some parquet files and the delta log. So under the hood, everything is exactly the same. So that's the first point to note about all these different data stores. Under the hood, it's the same data. So what is different then? Well, when we flick through to the UI, here we're in a Lakehouse. And I'm just going to give you a quick tour of each of the three data stores just so that you can understand what they look like and what you can do and some of the unique features in each one. So here we are in the Lakehouse. And what's particularly unique about the Lakehouse? Well, we have access to tables and files. So the Lakehouse, we can store structured data. So this is these tables. For example, here we can see a preview of data in these tables. But what's unique about the Lakehouse is we also have this files area. So the Lakehouse, kind of the definition of a Lakehouse is that it's part data lake, i.e. files, unstructured data, and semi-structured data. So data in CSVs and JSON, Parquet, whatever you want. And we can also have completely unstructured data. So image data, audio data. And if you're a data scientist, then that's really useful, right? Because you might be doing some image analysis, computer vision problem, all that kind of stuff. You're going to be saving your data into a Lakehouse files area. And one of the main kind of workflows that we use in the Lakehouse is to get data from an external system. It might be a REST API, might be files in ADLS, for example. We're going to bring them into our files area. We're going to pass them, transform them, clean them maybe, and then we're going to put them into more structured tables so that we can use them later downstream in our pipeline and visualize them in Power BI, for example. So for that reason, the Lakehouse is very often used as the bronze layer in the medallion architecture because it can handle both files and tables. So in terms of using the data in a Lakehouse or interacting with this data in the Lakehouse, the tool that we use is a notebook. So hand in hand with the data in the Lakehouse, we use notebooks to analyze or visualize or transform or validate or test all of this stuff. And you can create a new notebook just by clicking on Open Notebook. If you've got an existing one, you can link it to this Lakehouse, or you can create a new one. So I've got one here. I'm just going to click on here. So the thing to know about the notebooks is we can write code in a variety of languages. And the notebook is built on top of the Spark engine. So if you watched my 38-minute video introducing you to Microsoft Fabric, you'll know that the engine behind the Lakehouse and the data engineering experience in general and the data science experience, that is going to be the Spark engine. And because of that, we get access to 4 main languages that we can write in a notebook. We can use PySpark, Spark Scala, Spark SQL, Spark R. And that's if you want to use the Spark engine. So if you have really large data sets, then you're going to be wanting using the Spark engine because it's going to be able to chop through all this data in a parallelized way. And I've got a whole series about using Spark and notebooks in general. It's about a 4-hour-long video, and I'll leave a link to that in the description below if you want to learn more about that. But it's not just Spark as well that we can use in notebooks. If you've got slightly smaller data, you can just write conventional Python and use libraries like pandas and matplotlib and all this good stuff. That's also available to you, but you won't benefit from the parallelization that you get with Spark. So we can also create shortcuts in the Lakehouse. So we can create shortcuts to anywhere in Fabric. So this table here is a data warehouse table, and you can see there's a small link there in this delta table icon to indicate that is a shortcut. So this data doesn't actually live in this Lakehouse, but it's accessible to us in our notebook code, for example. Now, as well as the Lakehouse view, which is what we've been looking at currently, the Lakehouse also has the SQL endpoint. So we can write T-SQL scripts to view data in our Lakehouse. Now, the important thing to note here is that it's read only. So you can't do anything like alter tables, adding columns, update, inserts, deletes. You can't do any of that. Only really select statements. And you can also create views on that data as well. So that's the only real write capability, because the view is not actually altering the underlying data set, right? So here we get a view that looks a lot like the data warehouse, but it's actually the data in a Lakehouse. And we can write T-SQL scripts as well. And we can also create measures from this data, DAX measures as well, build semantic models and all that good stuff from this view. So next up, we're going to look at the data warehouse. So here we are in the data warehouse. And if you've used any sort of SQL database before, it's a very similar structure. So we have schemas, we have tables, views, functions, stored procedures, right? And the language that we're going to be using in the data warehouse is T-SQL. So we can write T-SQL queries and then we can save them for our colleagues to look at as well in this My Queries and Shared Queries option. So the data warehouse is going to be very familiar for database developers, SQL developers, maybe even Power BI developers that have used SQL before. So a typical workflow or workload that you might be doing in the data warehouse is more towards the end of the data processing pipeline, right? The gold layer of a medallion architecture, for example. You might be creating dimensions, creating aggregates, analytical models in here, because you might already have SQL code that describes business logic in your organization, right? And you're going to be using SQL to write those things. And again, you can create semantic models from your data in your data warehouse. Okay, so here we are in the KQL database, and I've got some data here just from the weather sample, which is the sample data set that you get in Fabric. So the KQL database really is built for streaming and real-time data sets. So we have a few different data sources that we can connect to get data into a KQL database. Now, some of these are like one-time operations. So if you've got a big batch of IoT sensor data for the last 2 years, you can upload it here and just store it in your database. But the main use case really for KQL is these continuous data sets. So we can use event streams or connect to existing Azure Event Hubs to stream data into the platform. So once we've got some streams set up, we organize things in tables. We can also use shortcuts, and we can also use materialized views. So if you've used Azure Synapse or dbt or any sort of database that incorporates materialized views, basically means we can create a view of the data, but then we write it out into a materialized views, which acts more like a table, and it improves read performance when we're, for example, querying it in Power BI. We can also create functions and data streams. Now, in this one, I haven't actually got any set up, but that's just to give you a bit of an idea about what the KQL database looks like. Now, in terms of languages that we're going to be using in the KQL database, well, the main one is KQL, and we can also implement SQL kind of as well. So here we've got a bit of a cheat sheet that's included in the documentation, and if you use this keyword explain in a KQL query language statement, it's going to output the KQL. So if we try that, then, so say for example here, I'm going to create a new KQL query set. Now this is going to take us through to the query set editor. And so if we only know SQL, then we can just copy this, and it's going to return a KQL query. And then if we want, we can copy that, paste it into our editor, and then just run that. And then we get the result. So if you're familiar with SQL, then that's a good way of kind of learning KQL as well. So that's a bit of a tour of the three main data stores that we have in Fabric. Now let's do a bit of a side-by-side comparison, just to summarize everything that we've gone through so far. And I'm going to be talking about a few other considerations when we're comparing between these three different data stores. So let's jump over to the iPad and I'll walk you through those now. Okay, so here we are down in the iPad, and what I've got is a bit of a side-by-side comparison of the three tools. So the three data stores that we have in Fabric are the Lakehouse, Data Warehouse, and the KQL Database, as we've just seen. And then to give it a bit of structure, I'm going to be talking through these things down the left-hand side. So what are the different data types we can use, the languages, Copilot integration, the different ecosystems that that particular data store might open up, which I think is very important, the different security considerations that we need to bear in mind and configurations that we can make in each of these, the typical workloads, the unique features of each of them, and the personas. And then afterwards, what we're going to do is look at some end-to-end architectures that combine these different data stores in some unique ways, depending on the requirements in your organization. So let's get started in this and talk about the data types. So we're going to be basically revising what we just spoke about earlier, just to reinforce what we were talking about. So let's start with the data types for the Lakehouse. And as I mentioned, we can do structured data, and by that we mean tables. We can also do semi-structured, so things like CSV in the files location, and JSON, for example, from a REST API. And we can do unstructured data, and by that we mean images, audio, anything really. And this is particularly useful for data scientists if you're doing AI projects based on computer vision or anything like that that requires the analysis of unstructured data. We need to get that data into Fabric, and the place we're going to get it in is in the files location in a Lakehouse. So the data warehouse, we only have the structured data, right? We only have tables really. Now KQL is kind of so we have the structured tables. We can also do semi-structured because we can import files that we can analyze in a kind of one-off batch scenario as well. Okay, so next up we're going to be looking at the languages. So for the Lakehouse, obviously we have access to the Spark engine. So we can write any languages that we can write with Spark. So for Spark, that's going to be Spark SQL, which is similar to T-SQL, but there are some differences. You've obviously got PySpark, did a long series on that, Spark R, and Scala. Now on top of the Spark languages, we can actually also write just raw Python, right? So Pandas, Matplotlib, Seaborn, all those traditional Python languages as well. And on top of that, we can also actually write T-SQL as well in the Lakehouse via the SQL endpoint. But that's going to be read only, right? So we can do select statements, but we can't do inserts, updates, deletes, any of that stuff. In the data warehouse, really, we only have T-SQL, right? So we can write queries, stored procedures, all that kind of stuff there. Now, one thing to bear in mind here is that if you have a table in your data warehouse, then it is an option to shortcut that into the Lakehouse, right? So this is my shortcut logo, very bad. But then we can create that here, and then we get access to all of these things as well, right? So just because you store your data in the data warehouse doesn't mean that the only thing you can do is to use T-SQL. You can still shortcut it into the Lakehouse if you need to use PySpark or anything like that, right? But natively, you only have access to T-SQL. And the T-SQL here, importantly, is read and write. So you can do inserts, updates, and deletes with data. So that's one of the main important things about the data warehouse, right? So the KQL database, obviously it is KQL and SQL as well. So in terms of Copilot integration here, so if you're using an F64 capacity or P1 capacity, then you get access to Copilot in the Lakehouse experience, or technically in a notebook, right? But the notebook's connected to a Lakehouse. So yes, that is available in the Lakehouse. Currently, there's no integration with the data warehouse, so you can't use Copilot to write your T-SQL scripts, for example, and it is integrated into KQL. So that's something to bear in mind if you want to take advantage of low and no code stuff, then Copilot is accessible to the Lakehouse and KQL. Now, I'm sure they will build this soon, but currently it's not available. And whilst we're on the topic of no code and low code, there's a few different options there as well for each of these. So with the Lakehouse, I'm just going to add in a new topic here, like low code, no code. Bit messy, but is what it is. So in the Lakehouse, obviously we have Copilot. We also have Data Wrangler, which is a feature that kind of helps you build Python queries, Pandas as well, if you're not too familiar with those languages. In the data warehouse, we have visual queries. So this is where you can create a query just using a UI interface. So if you're not familiar with T-SQL, you can still build queries with that as well. And in the KQL database, I don't think there is anything that's low code and no code. I might be wrong with that, but I think currently there's no options for no or low code. Okay, next I want to talk about ecosystems, because this for me is a very important point to consider when you're choosing a data store. So let's talk about the Lakehouse first. And because the Lakehouse is built on top of the Spark engine and we can use Python, this opens up the Spark ecosystem and the Python ecosystem if your data is stored in a Lakehouse. And with these, you get a lot of stuff, right? So you get things like machine learning. There's huge existing ecosystems in both of these tools. So for data scientists, really you want your data to be in a Lakehouse, and you can easily access machine learning libraries and build machine learning models on top of that data. But other examples might be things like data validation frameworks, particularly Python. There's a lot. And in the next video, I'm going to be talking a lot about data validation and how to implement that across all of these different data stores. Now, in terms of ecosystems in the T-SQL world with data warehouses, the good thing is that it opens up SQL projects. So we can manage our T-SQL code and our database configurations using SQL projects. And we can also use dbt, right? So dbt is a third-party tool that is very commonly used for analytics engineering. So what that means is we can use it as the transform tool, and it's all in SQL, right? So you can connect it to your Fabric data warehouse. You can use it to build aggregations. You can use it to build analytical models, all that stuff. And the good thing is that your code in dbt is source controlled, and there's a lot of functionality for validation. So this is a really powerful ecosystem to tap into if you're going to be using the data warehouse. Now the KQL database, I'm sure there are ecosystems, but I'm not actually aware of them. So I need to check that out. But I can't really comment too much on the ecosystems that the KQL database opens up. But it is a very mature framework, so I'd be very surprised if there's not existing ecosystems and tools that we can plug into that. Okay, so next up, I want to talk about the security configuration options with each of these. So let's start off with the Lakehouse. What I mean by security configuration is how granular can we get with sharing objects or rows or columns and that kind of thing in each of these? Well, in the Lakehouse, if we're using the Spark engine, then there's actually none. So we can't really do any of that if we're using the Spark and we're accessing our Lakehouse via notebooks. So that's something to bear in mind. I talked about this a lot in one of the previous videos about access control in this series. Now, if we're using the SQL endpoint, then you do get access to row level security. Now, one thing that I mentioned in my previous video is that this row level security is only enforced if you give viewer roles only, right? Because anything higher than a viewer role, so if you give them contributor, then technically they are going to be able to write a notebook, and then your row level security is not really enforced. So if you want to lock down at the row level for Lakehouse data, then you want to be giving people maximum of viewer permissions only. Now in the data warehouse, there's a lot more options for granularity in terms of what we can share with people. So we can share at the object level, which is a specific table, a specific view, for example. We can also do row level security. We can also do column level security. So if you want to hide particular columns from particular users or groups, then that is possible in the data warehouse. We can also do dynamic data masking, which means masking sensitive data in particular columns for particular people or groups. So if you've got sensitive information like an email or credit card, for example, that data can be masked in that column if you use dynamic data masking. So there's a lot more granular permissions that we can apply in the SQL data warehouse, if that's what you want. And in the KQL, we have access to row level security, and that's it. Okay, so in terms of the typical workloads that we have here, so if we look back at what we've written here, we can start to understand what the typical workloads might be, right? So if we start on the Lakehouse, well, the fact that we can have unstructured and structured data in the same place means that a typical workload really is getting data from outside of Fabric, parsing these files, getting them into a structured format. So this file to structured transformation is a typical workload that we can do in a Lakehouse. And especially if this file is complex. So if you have to do a lot of parsing, if you've got really nested JSON structure coming in, really you want to be doing that with code, right? Because it's a lot simpler than doing it with SQL or anything like that. So that's a particular use case that you would definitely use the Lakehouse and Notebook for. On top of that, any sort of machine learning, data science stuff, you're really going to be wanting your data in a Lakehouse. Now the data warehouse here, some typical workloads, we're going to be doing analytical modeling, normally in preparation for Power BI. So like dimension creation, facts, star schemas, creating all that stuff, aggregations, all of that. And for the KQL, obviously the main workload is for incoming streaming data. It's got a lot of inbuilt functionality for time series analysis. Now obviously you can use Python for time series analysis, but what I mean by time series in this instance is time series on real-time data as it comes into the system, right? Not just in a batch processing style time series analysis. So in terms of unique features for these three data stores, another thing that we haven't quite mentioned yet is Git integration. So in terms of the Git integration for each of these, the Lakehouse is an artifact that you can back up with Git. Now currently the data warehouse is not supported, but that's I'm sure will be supported soon. And obviously if you're using SQL projects, then there's an opportunity to use that as your Git integration method. And the KQL database as well, I don't think is supported via Git. Now some other unique features that I want to mention here for the data warehouse is table cloning. So that is particularly unique to data warehouse. And what that is you can create clones of tables in your data warehouse for development and testing, right? So if you've got a dimension table in your data warehouse, you can create a clone of that dimension table, alter it, change the structure of it, and then kind of test it out before then reintegrating it into your main code base, your main dimension table, right? So that's a feature that they released fairly recently. And if that's something you want to be doing, then just know that that exists there. Okay, so finally, personas, right? So hopefully it's fairly clear who's going to be using which of these. In the Lakehouse, typically we're going to be having our data engineers and our data scientists, because they're going to be the ones that are comfortable writing Spark code or Python code. They're going to be wanting using machine learning. They're going to want to be doing data validation, all that kind of stuff that is easiest in the Lakehouse. Now for the data warehouse, you're going to be having DBAs / developers, database developers, maybe Power BI if they know some SQL to create dimensions and facts and things like that. If they can create them for themselves, that's great. And the KQL is going to be data engineers, analysts who are comfortable with real-time and KQL. And yeah, that's basically that. Okay, so we've gone through quite a lot of different considerations there. Things you need to think about when you're choosing a data store. Next, I just want to finish by looking at some sample architectures, right? So taking into account all of this, we can begin to understand that some data stores are better suited to some tasks and others are better suited to others. So if we talk in general terms about the data processing pipeline, we have data coming into Fabric here, and at the other end, we're going to have a dashboard with your user on this end, right? And if you think about a sliding scale from unstructured or semi-structured, so these could be like files, API data, databases, and it's typical that these are in not good shape when they enter Fabric. And the goal is to gradually create more structure in our data pipeline, right? So as we move from left to right in this pipeline, actually this should be here. The goal is to clean, transform, add structure to these semi-structured and unstructured data sets, right? And normally that involves converting from this area might be files, and this part of the pipeline is going to be tables. So then when we think about how we architect a solution here, well, towards this end, really, we need to start at least with a data store that can handle practically anything, right? Because these are all going to be different formats. You don't know what format they're going to be in. We definitely need a place to store files and tables. So typically, we're going to start in an end-to-end pipeline with a Lakehouse because we can have files and we can have tables, right? So all of our files can get stored in here, data from APIs, even database data we might bring in and write it as parquet, for example. Then in our Lakehouse, we can create notebooks that validate and clean and transform all of this raw data. And then we're going to have some tables in our Lakehouse that would be like raw tables. Like we haven't done anything with them. We've just got the data out of files and put it into a table, given it a bit of structure, but we haven't done much cleaning or validation. Then typically from here, we want a platform where we can do data engineering and data science a lot of the time. Or if you need that in your organization, then typically what most companies will do is create another Lakehouse that's going to read in these raw tables and do things like cleaning, getting them into a more refined state, right? Now it could be conforming, and by that we mean merging different data sets into a single data set. So if you've got a customers table, you might want to bring in data from 3 different source systems and conform that into one table that is your kind of master customers table, for example. Also, this is where your data scientists might be working, right? So you might have some tables that take these tables here and then add another layer of insight, right? So it could be predictions or it could be some sort of data science analysis. So you're creating new data from your existing data. And then in this part of the analytics workflow, well, you're getting close to Power BI, right? And Power BI developers like structure. Now, either this layer, it's typically a data warehouse because you have to think about the skill sets available in your organization and who is going to be wanting to do this kind of stuff. So here we mean like creating star schemas, creating aggregated data sets that are going to be fed into Power BI. And typically the people that are building these things are a lot more comfortable with SQL. So that's why in this layer of our pipeline, a data warehouse makes a lot of sense, right? Now you could have just Lakehouse, and Lakehouse here, but it would require people in your team to know Python. So they'd have to build all of these things, like your dimensions and your facts, in Python, which is possible, but it's not what most companies do. Now, the way that you would integrate a KQL database into here is if you had streaming data, then you'd probably want a KQL database here. So you could create an event stream that's getting stored, analyzed, and processed in your KQL database. Now, what you can then do is then route that into your silver layer of this medallion architecture. So once you've kind of got the insight, you've done some analytics in real time, then you probably want to save that data into more long-term storage on this Lakehouse. So that's how you would integrate a KQL database into this kind of architecture. But all these things are highly dependent on the skills that you have in your organization. So hopefully now, it's quite a long video, I've been talking for a long time, but I think this is really important the material. People are making these decisions about which data stores they're going to be using in their organizations. So hopefully now you have a better understanding of the key features for each of these, some of the limitations, some of the things you need to bear in mind with each of them, so that you can make good informed decisions about when to use each one. In the next video, we'll be focusing on data validation, and this is one of my favorite topics. How do we introduce data validation into an architecture like this to build a system of data quality assurance at each stage in your data processing pipeline? So make sure you join us for that.